This is the last little bit that Alan looked at, and that was the z-scores and the z-distribution. Now, some of you may know the z-scores through statistics, and a z-score is basically a normal distribution where the mean is 0 and the standard deviation is 1. So a z-score of 1 means that the mark is 1 standard deviation above the mean. A z-score of 2 means it is 2 standard deviations above the mean. A z-score of -1, that's -1 standard deviation above the mean. And it's just a nice simple bell curve. So, and for this, we really need the tables. So let's have a look at the first one. The probability that z is greater than or equal to 1.3. Now remember, the greater than or equal doesn't really matter. If it was z is greater than 1.3, it's exactly the same. So here we're going to do z is greater than or equal to 1.3. So on our little curve here, that is this area here. And that is the area that exactly the table gives us. The table gives us that area. So that's the area we're looking for. So we look at the tables. We're after 1.3. 1.3 is 0.0968. So that area, that's the area that gives us the area above 1.3, it's 0.0968. So this is 0.0968 or 9.68%. And that's all it is. That's exactly what the table gives us. For the next one, we want a z-score. What is the probability that the z is greater than or equal to 0.13? So again, we'll look at our table. 0.13, here's 0.1, and we go across to 3. So this is 0.13, which is 0.4483. So 0.4483, we want greater than, so 0.4483. We want this area here because it's greater than. And that's pretty good. That's what we would expect. About 44.83% of the time, our z-score is going to be above 0.13. So now some of these can get a little trickier though. For this one, we want P, the probability that Z is less than 0.5. So really, we want this area here, which is opposite to what the table gives us. The table is going to give us this area. So let's look at what that area would be. It's for 0.5. So 0.5 is 0.3085. There's 0.5, 0.3085. So we know that this area here is 0.3085. The whole lot, the probability distribution, the area under the whole curve is 1. So if this is 0.3085, this side here must be 1 minus 0.3085. So 1 minus 0.3085, 69.15%, or 0.6915. Similarly here, we've got that we want the probability that Z is less than or equal to 1.1. So we want this part of the graph, or this part of the function. Now, the z-score tables doesn't give us any minuses. So we want the probability that Z is less than or equal to minus 1.1. So we want this part. Now, because of symmetry, that is going to be exactly the same as this part. I always like to draw the pictures on the because I think it just makes a bit more sense to me. 1.1. So what is the probability that it is greater than 1.1? In other words, this area here, we can get that straight from the table. 1.1 is down here. Here's 1.1, 13 or 0.1357. So if this is 0.1357, this side is exactly the same through symmetry, so it's 13.57% or 0.1357. So that's the probability that Z is less than or equal to -1. The next thing Alan did was look at this situation. So we want the probability that Z is between -0.54 and 1.23. So on our little diagram here, it is this area here that we're after. So I'm going to break this up into lots of little parts. First, let's find this whole area. So this is the first thing we're going to find, this whole area here. How do we do that? Well, the table gives us this part. So let's find out what this part is. 1.23. So we look at 1.2. 1.2 and we go across to 3. This is 1.23. 0.1093. So this area here is 0.1093. We don't want that area. We want the other side. So that this side here, the one that we want is 1 minus 0.1093. So this side from the table is 0.1093. So this side is 1 minus 0.1093. And that gives us an answer of 8907 or 0.8907 or 89.07%. But then we've got to take this part away because we don't want this whole area. This is this whole area here. So the next thing we want to do is find this little part here or this part here and get rid of it, take it away. So how do we find this part? Again, the table doesn't give us negatives, but we know this part is equal to this part. So instead of looking at minus 0.54, we're going to look at positive 0.54. And again, we can look at the table, 0.5, 0.5 and across to 0.04. So this is 0.54, 29.4, 0.2946. So this is 0.2946. So this side is exactly the same, 0.2946. So what have we done? We've found out the whole area here to be 0.8907. We've found this part to be 0.2946. To find the area that we're actually interested in, it's going to be this minus this, or we're going to take away that area here, which is equal to that area. So it's just going to be the 0.8907 minus the 0.2946. And again, we've got calculators that can do that. Equals 5961 or 0.5961 or 59%, 59.61%. And that's basically the lecture from Monday night. Thanks.